Good morning and good afternoon to everyone. We will be waiting 5 minutes so that everyone can join the webinar. So I will speak to you soon. So good morning and good afternoon to everyone. I know we have an international audience here. My name is Isabel Milan from Media Marketing and Communication, and we are happy to present another webinar from Vidia. Today we are going to speak about modern economics of metal cutting. And as Vidia, we offer every week courses on several topics related to metal cutting. We are covering a series of languages from English, Spanish, Russian, Italian, and German. And to receive any information on all the courses that we do every week, please subscribe to our video newsletter. I put the link in the chat. I promise that we will not send you many emails, but we will only send you relevant information on video products and training courses. So today we are going to have a presentation from our regional product manager, Vladimir Zherebtsov, and he is going to do more or less 30 minutes of presentation, and then we have the questions and answer session. So please write all of the questions that you have throughout the webinar. You can find the question panel on your right. With the orange arrow, you can open the control panel, and there in the question section, you can write your questions and then press enter. After the webinar, you will receive the recording. If you don't receive the recording, or if you want to have any recording from the previous webinars that we did, please write us an email. You can just reply to the registration email. And I will leave it to Vladimir to start our presentation. Thank you for listening, and we'll speak later in the questions and answer session.
Hello, everybody. My name is Vladimir Zherebtsov. Today we will talk about money. So generally, a lot of us probably now during this situation are thinking about this. But anyway, during the whole metalworking history, the one of the main questions was how earn more money from also production, metal cutting production. So we will touch several topics. Also in the second part of the presentation, we will calculate live the cost per part, and we'll understand which parameters influence on that more, which not a lot. Before coming to that, I wanted also to show to you some trends, because they influence on how we should be serious with economics during last years, last 10 years, last 20 years, and last months, because of different trends. Which trends? For example, one of them is near net shape. We should cut not that a lot of stock to remove than in the past. Also, it influences on cost, because one of the big portion in cost is raw materials. Also, increase of technological capabilities last year. So machine tools becoming more and more interesting, more and more universal. So 5 axis and with more and more things they can do. And also it can influence on, depending on the type of production and order to produce how many pieces, also depend on this. Significant increase of number of competitors, I mean competitors of metal cutting companies. So a lot of big companies also and small companies, they have tier 1, tier 2 companies which produce components for the main companies with lower prices, basically. So, and they compete also with each other. In some countries, in some cities, you can face productions, different companies which are situated one in front of another, maybe a road between them, but they produce completely the same products and they compete with each other. And how to compete? So of course, with quality, and of course with prices, and of course with money they can get after they sell their products to customers. I mean, more they can earn, more they can invest for future production, for future products. Also, not a lot of time to react for market changes. So yesterday we should produce some cars, and today we should produce masks against virus, for example. So it's maybe too critical comparison, but anyway, we have similar things regularly. So some production should adapt, or maybe market should adapt to newer needs. Change price of natural resources. So also it's play big role in an influence on production costs. And 3D printing, it's another trend. It's like a market change. So a lot of components. Also, we partially produce cutting tools, partially, I mean, some of them using 3D printing technologies. And also in future, so it cut time a lot. So you can machine in, you can produce the component with a more interesting form or shape. But before 3D printing, you can produce it in 2 or 3 machines. So you can do it in one machine tool instead of several. So how it influence? Also, it accelerates the world. I mean, all these trends accelerate the world also because of changes. For example, product life cycle. A lot of products, for example, mobile phones. Also, it's also not the same but similar. It works in cutting tools and machine tools. People need new models every year, or maybe every 2 years at the maximum period. In order to do that, it's not possible if we are not working efficiently. To work efficiently, I mean, if I'm metalworking producer, I need to decrease to decrease time for production and to accelerate my production and to increase metal removal rate. To do that, to also to machine more different components on the same machine tool. I need to produce first batch faster and then to produce another batch of another products and so on. Also, in metal cutting productions, a lot of years there is a trend to use fast tool change, modular systems like PLC, KM, and HSK, because also influence on production of every component. Also, the world has been accelerated, and also new product development depend on it. Also, because every 2 years, every 3 years, every year, the market need new products which are better than previous ones and to bring more successes in metal cutting, for example. Acceleration of product introduction. We cannot introduce product during 1 year or 2 years. We should introduce it, and your car, your airplane, during several months, or shorter and shorter. We don't have enough time, because we should think after we introduce this, we should start to invent the next generation of airplane, in which we will introduce in 3 years or in 2 years. Also, a lot of producers, metal cutting and also cutting tools, they given more chances to test a product before it's introduced to the market. It's a common R&D project together with customers, together with companies which we will use this product in future. And also, we should come to the tool, to choice of the tool wisely. So we should choose the tool which brings the maximum efficiency, maximum productive or maximum universal, depend on the type of the workshop. So it can be mass production, for example. They should be used the tool with maximum productivity. For example, video drills top drill S for different materials. So each series is designed for maximum results, for maximum cutting speed. Or vari drill, for example, if components have been changed very often during the 1 day. Several types of components should be machined. Not that fast, like by TDS, but VDS, vari drill from video, they can be machined faster, because there is no any need to substitute the tools. So the same tool can machine everything. It's just an example. And also, why tool is so important? It's slightly cheap. I mean, if we compare with expenses on production of the component of the product, the share of cutting tool is very small. It's a 3% or maybe 5%. But how it can work, what it can bring, how it can shorten the time of production, it influences on the rest 97% a lot. Also, another consequences influence on a cost of products. It's production migrations because of the labor cost. It's also big, slightly big portion of metal cutting expenses. A change of logistics and resources and supplier sources of spare parts, for example, also depending on that. Electricity and transport heavy optimizations also because of taxes in some regions of the country, of regions of the world. So some give a very good discount on taxes, if I can put it so, or and electricity. And also very big factor is degradation of competence among people near the machine tool sometimes. It's not because of degradation of people, no. It's a degradation of a situation when a machine tool is smart enough and people are not needed anymore for this machine tool, only to maybe to help to substitute workpiece. And that's why in a lot of cases, companies are asking us also to help with technological processes, because in some companies, metal cutting companies, there is no technologies department anymore. And also we need to calculate sometimes almost everything which concerning metal cutting. And I have a short poll before we will continue. I will launch it a little bit later, maybe in 2 slides. So what we can do to improve the situation and decrease the cost of components which have been produced by metal cutting. It for sure, as a, for example, metal cutting company, we should have stock and deliver tools on time. Also to show in our catalogs the different types of tools which can be used for different types of productions in workshops. For maximum, which dedicated for maximum productivity or maximum universality. We also should share our experience with our premium customers which need our help a lot. For example, we do it in aerospace initiative. We have experts at Center of Competence which help decrease time for production of components of the product and to bring a lot of money, a lot of savings to our customers. And the same is like to utilize competence in different types of metalworking. Also, a lot of companies try to test more and more tools in advance together with the customers, not only in the lab, because we cannot simulate all different situations in the labs. We have a net of labs depending on the R&D centers, depending on the tool. But also earlier we are testing our new designs of cutting tools together. I mean, after preliminary test for sure, together with our premium customers. And for sure, regular frequent visits of workshop to change tooling according to the maybe changed situation in the workshop. So in order to adapt, in order to not lose money, I mean, by customer. And also to understand expenses and to show benefits to every customer. How we show benefits to every customer? Usually, after video distributor, for example, visits the customer, we are shown the report we make after test of our new tool, of, for example, new Top Cut 4 drill or TDMX drill or new turning geometry. We usually showing the report which showed tool life, which is showing tool life, and also showing expenses. In addition, I mean, when it's needed, we show it also. You can see here different pages from this report. Also, maybe the page in the middle, green one, is you are familiar with that because it's our regular tool report with comparison with against different producers, and also the sheet on the right side is showing what economy, what saving we are bringing with these test results. I will try to show it closer in a PDF document. 1 second. For example, here we optimized technology and brought economy per year about £5,000 at one customer. So how we did it? I mean, usually by using the modern cutting tools. By the way, Isabel mentioned that you have a menu on the right side of the screen. You can open it, and there are different tabs there, and one of them called handouts. And if you open there, you can download from there 2 PDF catalogs from VIDIA of our new tools. One called All Star, so the most popular tools, new tools, modern tools, and one is the latest generations. One of the way to bring the maximum annual savings to our partners, I mean, companies we are working with, metal cutting companies. It's a usage of a latest generation of tools. So generally, if you want this from video, you can download these PDFs, maybe after webinar, not necessary to do it now. So under tab handouts. So let's continue. You can see here the calculation of cost per part of first variant and the second variant, and saving is about 50%. How it was done? Because yeah, there was some conditions, cutting conditions. How it was done? We introduced the next generation of cutting tools was Vladimir 2 with MEC and with a new generation of carbide grades for solid end milling. And also, and by this way, we increased tool life, but not only, we also decreased the time for production, because our metal removal rate, for example, increased from 16 to almost 20 cubic centimeters per minute. And this is a general report, but you can ask, where did you take these digits? How to calculate this? Usually we calculate it by ourselves. We have some formulas, but also we don't spend time for that because our engineers in your past made this report being made automatically. So that's why it's been done automatically if you put all prices there, and also machine tool cost per hour also we put to our program automatically. But how to understand this cost, how to calculate what it consists of, we will try to explain it during this webinar. So during this webinar, we will talk about company tasks, but you know what company task. If it's not social company or government company, the task is bring money, earn money and bring more profit. Cost of product, what it consists of? Cost per part or cost per component, how would you like to call it? Cost per metal cutting operation, so generally cost of doing which had been done during the production. Machine tool costs, real cutting tool cost and savings, so final report, final value, which is very important for all of us. So company tasks. So basically, a company should sell their product to customers. Products can be different. It can be car, electric cars, or cakes. It doesn't matter. So for the production, there should be several things being used, or they should have several things. It's an area when they will produce this product, if they're not just resellers. Or even the resellers, they should have warehouses. Methods of economics they're the same. You can also use it in your private life, for your home, for your house, for your budget. Electricity, raw materials, operators, because the machine tools, so far, not every machine tool can work without operators, without labor cost, without us. And for everything, money should be spent every year, and for some every month, for some every hour. And this all should be spent to get a ready product or ready component for the product, so part of the product. sometimes plant or enterprise and company, they don't have money, so they should take a credit from the bank. And after they earn something, they should give this money or this increase, I mean, this percents back to bank. So also it should be in the mind when we talk about the prices also and costs. So what is the cost per product? How it can be calculated in basic things? So for sure, we should buy work pieces or metal. We should have metal to shape somehow, because it's not that ideal even in modern life. After that, we should have a thermal treatment, hardening or something like that. For sure, control, measuring, and people should be calculated in that. So in previous slide, it was showed in a very easy way. As for questions, I see you are started asking questions. Please continue asking, but I will try to answer in the end of the webinar because of time limitations. Assembling and packing also should be done if component or product is complex. So it's not just one part, it's assembling of different parts. And altogether, what usually customer buying for what? For price. Price is the cost plus profit, but profit should be spent on a lot of things. For example, for promotion, not promotion, for information of market about this product, because nobody will get to know about your new car if you will not share the information in social media, in magazines, or in special marketing activities on exhibitions and so on, open houses. So, but it takes money. So it's working of marketing department or sales department. Delivery also, it's not included into production costs. So it should be taken in mind when we calculate the price. Custom clearance taxes, sometimes it's a lot of money should be spent for custom clearance control, and also certification on different countries like Germany, Russia, and so on. Sometimes it's a lot of effort should be done there. And a lot of money should be used for research and development still. Yes, this product is developed already, but it will not last forever. So after 3 years, it will be obsoleted, and every company should think about future products, next one. So work with universities, and they also need money for some investigations, for research. Also maintain own R&D departments, and they also take a lot. Sometimes this it's bigger money than the rest of which we showed here. And altogether, profit and costs, the sum it's a price, and more or less it's a market price. So usually we cannot make it higher. So sometimes we should do some cost reduction somewhere to be on market. So, and here now the short poll. Please, can you answer during the about 1 minute, and we will look at the result after. Just before I will continue with the main topics, it will come closer to how it's possible to calculate and to live calculation. In your experience, what is the most important parameter which decrease cost of component of machining, which improves the economical situation and decrease expenses on production of metal cutting component? Tool life of the cutting tool, taxes, salary of personnel, or machine tool cost per hour? So we talk about cost of component, not on cost of tool or something like that. Cost of machining of component. Okay, I see the trend. Thank you very much. Let's see and talk about it. Let's see the result and talk about them. So a lot of people, a lot of you asked the tool life of the cutting tool is very important. It's very nice to see this. And also another variant, the second place is machine tool cost per hour. It's very interesting results because you know that the cutting tools have been improved every year and every 10 years and every 100 years. So since first carbide was introduced on the market in 1925. Why it was introduced? Because of the tool life, maybe, but there was a much more demand there to produce more and more pieces made of steel, made of cast iron in that years. And machine tools could able to do that, but cutting tools not. I mean, yes, these things, they are connected, tool life and productivity, but more influence on this improvement of cutting tool materials, the cutting tools in general, influence, the maximum influence on this is productivity, and productivity because of the cost also, because of the plan. Sometimes industry have a big demand on quantity of components, and when is the competition, you need to decrease price in order to continue to compete. And the very big portion is machine tool. Basically, it's about 20%, but it can be different from 20 to 40%. It's just not average, but just an example. A lot in the cost of product, big portion is for sure raw material. Also, a lot of a big portion is salary of workforce or labor cost, so-called. Machine tool cost also a lot. Why? I will show it in a live example later. At least you can calculate per year what is the salary of people which working on production of this component, of this part. Machine tool cost, how much it costs per year, per month, and so on. Additional administrative cost, also it's slightly a lot. So in order to everything is being functioned in a good way, there should be additional spends also to be used. But if we analyze how much we spent on coolant or on cutting tools during the machining, it will be from 1 to 5% on each. So approximately 3–5% on cutting tools and 3–6% on coolant. That's, for example, second is one of the reasons why more and more companies prefer to work without coolant, also because they want to cut this 6% as much as possible. Not only, but one of the reasons is that. Let's try to, I will try to explain deeper to show to you 3 different scenarios, how cost and profit, and together is the price, will be changed. Price we cannot change because it's market price. It's a very in general, we cannot change it because competition determine the price. So we can operate only with cost and profit, what we can allow for R&D, profit, and cost, what we can do during the production. So basically, cost of product is consisting of raw materials, spare parts, assembling, and metalworking. Metalworking can be cutting and also grinding and also all these things we mentioned earlier. But basically, the biggest portion is metalworking. So how we cut off the chip from the workpiece. So let's analyze the first variant. For example, a company wants to buy cheaper tools, cheaper poor cutting tools. It's a very good producer, so we will compare with him several times during this presentation. So, for example, 2 times should want to be saved by buying cheaper tools. What company will get after that? So usually it's about 5% in cost of product. It's about 5%, which is taken by tools. So if you buy 2 times cheaper, you will save about 2.5% only. That's good. That's good saving. Not bad. If $1 million costs this product, it's not that bad. But if to analyze deeper, if it's a really poor cutting tools, cheap and poor, and maybe old, it's hardly that it can be used on the same machine tool rates. So hardly it can survive in the same cutting data and show the same results. So in most of cases, poor tools, cutting tools, they will machine this component, but not that fast. So a production cycle will be increased. And if it's increased, it will cut our profit. And it will cut not 2%, so maybe 20% and 15%. Just saving on cutting tools can bring this loss in profit. And if profit is not that big, if competition is very heavy, so profit is minimum, so it can be a loss in economical results of the year and bankruptcy after that. And only tools, so just like a peanuts, 5% influence on the life of the company. The second variant, for example, let's increase tool life. Some of you voted for tool life 2 times, or get 50% discount, which approximately the same. It's not that same because we need to understand the time for the tool changing and so on, but it's more or less the same. We want to increase tool life 2 times. So basically our expenses on tools per year or per component will be cut 2 times. And again, we will get saving 2%. It's more or less good. Maybe good if it will cost. So it's not just like this. You need to test these tools if they work normally and so on. So your technologies should spend time. They also we should spend salary for that. And if it this savings 2% is greater than efforts made for this being done, it's good, but also it's just 2%. It's economy and savings of cents, but not euros. And the third result, if we buy normal tool with normal price and normal quality for sure, then we can work faster. And new cost decrease dramatically. So because of shortage of production cycle time, of machining of this component, and profit is grown also significantly. Yes, maybe this tool is 2 times more expensive. Okay, there will be not 5 but 7% increase of expense, but economy on time of this super expensive and very valuable, maybe the most valuable things like machine tool, which cost $100,000, and people which also can cost the same per year, is bringing, because they spend their time less here if tool working faster with a higher cutting speed, with higher metal removal rate, Q in centimeters, cubic centimeters per minute. In teaching books, you can find the formula for this. Oh, ask us. This is bring the maximum effect. So at first case, it can be a final day for this company. The second place, it's just spending a lot of effort for almost nothing. In the global way, I mean, in the way of cost of component. And the third can bring normal economy and savings, and can improve effectiveness of working, and will let this company be the better competitor than others. Let's talk about another case. And also, I forgot to say that this can be implemented on every part. Together with all tests of different tools, you can sum everything, to collect everything, and to get cost of part, then another part, and then another part, and calculate economy for all products, for all car, for example. So, and can get a new profit from not from all workshops, so to get maximum result. And another comparison with cheap, poor old tools. But here in this case, they will be in these conditions. Steel workpiece, plate 2 meters with about 50 millimeters, but doesn't matter. Just example. Machine tool DMC, not DMG. DMC, it's a much cheaper one with a machine tool cost about 25 euro per hour. And let's talk about comparison with old cheap tools and modern ones and slightly expensive. So CPO tools in the first column, and the second is we can talk about our tools in the third column. You can see here prices, for example. Okay, we can talk about also free of charge bodies, for example. Here, let's imagine that it's free of charge. In some countries, such old tools are still stored on big warehouses, and they are free of charge, and we should compete against them also. It's not virtual, it's real in some countries. So you can see also not bad insert with 5 cutting edges. Insert price about €1. Tool life after test is about 5 plates. Cutting data, you can see feed per tooth 0.2, cutting speed 90 meters per minute. Depth of cut 4 millimeters, and feed speed, so it's millimeter per minute, 364. We could machine one component during the 5 minutes by using this first variant of tool. Let's took modern tool, for example, milling cutter Video M1200, which cost about 500 euros. I mean, tool body with the insert designed for steel, so WP40 PM. Insert cost about 25 euro. Tool life per edge significantly increased because this is uncoated, this is a coated, so you can see the difference also in that. Feed per tooth is okay. We can choose 0.2 also, but we can use more. And the third column showed how cutting data influence on that. Cutting speed the same. So in a lot of cases, companies are asking just to substitute tools, just to increase tool life. You can see the tool life increased. Where is it? Yeah, here, 30 pieces versus 5. With the same productivity, yes, it's increased a little bit, but it's also around 400 millimeters per minute. So it's the productivity or speed of our machining. But time per component, if you didn't increase anything, will be approximately the same. Yes, there is a 5-10 seconds saving in time, but it will bring savings, but not much. I mean, according to calculation, because of this machine tool, DMC, for example, because of the average price or cost of expenses which we spend for operators, it will be approximately the same. So there will be savings, but not that much, and maybe not significant. Yes, also because this is a free of charge almost. So prices inserts cannot be free forever because it's the most wanted material cutting material. It should be substituted slightly frequently. But let's look at the third variant. We will take the same tool with the same prices, but increase cutting speed about 2 times, and also 2.5 times feed per tooth. And this geometry is doing it easily, 0.35 millimeter per tooth. By this, our tool life is decreasing dramatically, but still higher because it's a modern tool. And what we can see, not because of the tool life, but more because of value of feed speed. It increased dramatically, so 6 times approximately. And the time per component decreased from 5 minutes to less than 1 minute. And here, calculation is showing us that machining cost is 2.5 euro approximately, just per one component. And you have mass production, so I don't know, 50 or 30 or 100. You can multiply it, and you can get about 1,000 euro just per batch. Just savings, and just you can invest it in your people, increase their salary, for example, or technologists who made this done. I mean, usage of modern tool in comparison with old one. So I hope it's more or less clear, and let's try to calculate it and to explain, to understand all parts of calculations together. Here, there is a small document which has been showed. Hope you can see here it now. It's Excel. And we tried to separate it on different things. Machine tool rate, I mean, below you can see this on the screen. Cutting tool rate and the cost per part, so final calculations. But one of the interesting questions is how machine tool cost. What is the cost per machine tool per 1 hour? And not only because machine tool cannot work without people, cannot work without electricity. That's why I combine it all together in this slide. So let's talk about first point, machine tool cost. So basically, let's talk about machine and how to calculate how it can cost per hour. So how to calculate expenses in general? We need to calculate all expenses per year. And this year, we should count during this year how many time we can earn money during this year, how many hours, because a year is 365 days. But working ones are not that big. Different countries is different. So it's about 260, but also depending on the holidays and also vacations, corporate vacations and so on, it can be different. It should be taken into account. It influences a lot. It's 2 times, 3 times influence on machine tool rate. So machine tool model, let's, for example, look this one. How it can be cost. So which price was spent, which expenses were for buying this machine tool with everything. So it's about 300,000 euros. Maybe it can be more. So if I'm wrong, I will. So please let me know in the chat. So I'm trying to read it now also. But basically, in every company, this price is not forever. I mean, as in every product, you should think about the future. So more or less, in some years, this machine tool will be worn out. So you should substitute it by a new one. And in economics, in the accounting department, usually there is such a term like amortization. So amortization, so it's a number of years after number of years after which quantity, I mean, of these years, this main spends, I mean, for example, spends for this main expense for this machine tool will be 0. So basically, they usually in different countries is different. For example, it can be 10 years. In some European countries, I know this 5 years. It's depending on the government standard or company standard. So let's look, for example, 5. So for 5 years, a company should earn money to buy this machine again. yes, it should be also calculated inflation and so on, but in, for example, Europe is minimum inflation. Maybe it's not that big influence on that. So you can see that, for example, we bought it for 300,000 euro, and every year, so we should divide by 5. There will be approximately machine tool rate per year. But here it's not 365 days. It's only working days and working hours. So basically, we need to understand how many shifts. Usually, it's one shift. Very often, of more successful companies, it's 3 shifts. And shift can be different. It can be 8 hours, or can be 2 shifts by 12 hours, for example. Number of working days per year. So here we should delete days for vacations and also for holidays. So, but very often 260 days per year. And very interesting coefficient of effectiveness of machine tool, because if it will work permanently, sometimes you need to make a maintenance. Sometimes you need to also make a substitution of something, also components. So it not work 100% of time. So it's not that effective. It's most effective in mass production, in production line, with maybe special machine tools, not just universal like we face every day. So basically, its coefficient is about 0.5 to 4.7. So basically, it's will show to us how much time of we what we have, how much time we can use for production. So basically, after calculations of that, so basically we can get that it's about 30 euro per hour we spend for machine tool. And also total production time of working, it's 2,000 hours about. So it's a first. Also, we need to understand how area, it's not for free. Also, I'm not sure in different countries it's different, but let's think about 0.5 euro per square meter companies paying. And for average size of machine tool, we should have approximately 15 square meters. Also, not only for machine tool, also for equipment, also maybe some tooling. I mean, some for making assemblies with the component to the table of the machine tool and so on. So here it's about 0.04 euro per hour. So you can see that's miserable. And per year it's 90 euros. So maybe in some countries it's more. So maybe it's 1. Okay, it's a little bit greater. Labor cost. So cost per machine tool operator, and also it's in a different companies at different cost. So basically it's a salary per month. Okay, about 1,500 euros. And the number of machine tools also should be taken into account, because sometimes operators they're working like working not only on one machine tool but on 2 or 3, and then they are making programming and so on. So it's just easy to you to show how it works. For sure, it's a little bit more complicated in real life, but big things, big values can be understood and showed after this even that easier calculations. Tax in some companies should pay tax for every employer, so it's usually 20 to 30% of the salary. And additional administrative expenses, usually for functioning of operators. For example, they need a coat, they need gloves and something like that. So about 5 or maybe 1% or 2% is been. Also, we can add more things here. It's Excel. It's possible to do everything. So it's area. It's electricity. Electricity, depending on how much electricity has been taken by the all things which are producing this component on this 15 meters. Usually it's machine tool. Machine tool have a machine power 20 kilowatts, and approximately we will spend €2 per hour if the price is 0.1 euro per kilowatt. But it's different. So in Europe, I suppose in Germany it's much more expensive. Maybe it's I don't know 4. Maybe it's 1. So it will be 20 euros. So it's a lot. Maybe it's too much. I was used here. Basically, it's better to ask company which you are visiting what is the machine tool rate, because sometimes in some companies they know this value and what is included inside, only machine tool or altogether, like I'm showing here. For example, here we see that machine tool rate together with people, it's about 45 euros. And you can see that the first place is machine tool cost. The second place is labor cost, and the third is electricity, and the area is minimum. So it can be different, but usually in average, machine tool cost will take first place, and very close to that is labor cost with the machine tool, also depending on the price of machine tool. So comparison of price and salary. So even like it's written here, even if price will be 0, you can see the machine tool rate is 20 euro. So if somebody make a gift to you and on your birthday, so gave to you a Hermle C20 machine tool, you should understand that you will spend time and money also slightly a lot. Cutting tools. Let's talk about cutting tools. So let's talk about turning cutting tools. Yes, it's a milling machine, but let's talk about turning because it is easy to understand here, because we don't have enough money, enough time, sorry, for this delay. So price of cutting tool body of this holder, of turning holder, is about 100 euro, maybe less. So here probably the same if we don't change anything. Here the two variants. When we compare with another producers, for example, number of inserts, 1, tool body, tool life, usually it's 400 indexes, depending on the tool. Turning 200, milling about turning 400, milling about 200 to 150, depending also on the type of tool. If it's a heavy turning, heavy milling, it will be less. I mean, tool life, how many indexes you can do before it will be worn out, depending on the cutting conditions. Inserts, for these inserts, let's put this insert, but it doesn't matter. Grade 1. And here you can put maybe the same, many things. Usually it's the same values for, maybe price can be different if it's a different supplier. So price, approximately, I don't know, 5 euro. Here also 5 euro. Number of cutting edges. So if cutting edges in the corner of 80 degrees, so it should be 4. If you can use all cutting edges, it can be 8. And you can see here the expenses per 1 index. Why per 1 index? Because it's influence on results also, because it depends on what's the real tool life will be. So basically 1.5 euro per 1 index per 1 tool life period you will spend every time before they will be completely worn out. Time per indexing, yes, also I missed that. So 1 minute approximately, maybe less sometimes, maybe more sometimes, for changing of the cutting edge. And results. So you can see here different, it can be different results. For example, here we are putting here tool life per 1 cutting edge in minutes and in pieces. For example, here it was a result of 50 pieces, and in minutes it was or I don't know, 10 pieces. And in minutes, it was about 40 minutes. Time for machining of one component, it was 4 minutes automatically. So this divided by 10. And time for workpiece change we should add. So it's about 5 minutes, can be or 3 minutes, doesn't matter. Machine tool rate was taken from the first sheet, 49 euros. And so it's a results of one. So this we are taking from this test report, tool report, tool life, cutting date, and so on. Here, just economical calculation without any types of wear and so on. And let's imagine another situation. We are spending only 15 minutes and get the tool life approximately, I don't know, 8 pieces. So tool life in pieces is smaller. Tool life in minutes is smaller. You can see, oh, it's a tragedy. How it's possible? But you can see here it's time for production. It's not 4 minutes, but less than 2. Yes, it's here also big digit. But anyway, so you can see after calculation, we see that using of variant 1 tool with this results is taking from us about 3.5 euro, while using of another variant, which is working longer in tool life, is taking more. So yes, 1 in 15 cents more. But if we took a batch 1,000 pieces, you can see that 1,600 euros per batch you will make a the saving. So basically, tool life is important, yes, but you know that a lot of in catalogs, cutting producers showing the cutting data in turning tools, which are relevant to 15 minutes. Why 15 minutes? Because it's statistical tool life, which allow to get minimum cost per part in turning. In the milling, it's about 40 minutes, 30 minutes, so it's a range. In drilling, so also the special value, but in turning, it's a 15 minutes. And if you're in normal cutting data, in higher cutting data, you'll get 15 minutes, it's very good. It means that you will get a maximum result. How to understand where is your limit on your production? You need to make several tests. For example, I will switch to presentation. Also, we are near to the end. 1 second. You need to test the same tool in different cutting speeds. And to calculate according to this theory and practice, so according maybe to your one. And to compare. And usually, 1 second, yeah. And usually, if you increase cutting speed, you will get 3, 5, or 6 or 1,000 points. You will decrease the tool life. And if you calculate in different cutting speed, for example, 100 meter per minute, 150 meter per minute, 200, and you will see also what's the tool life after test for sure. What is the tool life? Here will be, for example, 5. Here there will be 20, and here there will be 15. And usually, after your tests, not mine, it's not a theory, it's just from practice, from statistics. Usually the graph will be like here. So range between 15, maybe I'm not so precise here. So from 15 to 20 minutes for turning will be a range of tool life on normal cutting speed, and it will bring the minimum euro, so minimum cost per part. So generally, I'm finished. If you have any questions, please ask here now, or also after this webinar, after we close it, you will get an email with survey, and you can write there the quality of the webinar and also your questions. Index is in indexing of the cutting edge. So sorry for these terms, but usually we're using with cutting tools with indexable tools, so which can be rotated cutting edges. So just it's substitution of cutting edge. Machine tool effectiveness, it's a coefficient of effective time, which can be used for working of machine tool, because sometimes there is a maintenance, sometimes it's staying for substitution, so to wait for substitute the components and so on. So that's why our machine tools, they're not 100% of time they are working. There is a time they are still staying, unfortunately, and we should decrease this time. So we should use only time which it can work, and we should earn money only when it can work, and we should calculate it. We should take it into calculation. PDF report of a metalworking, yes, we are sending right after we making a test. So we all things, I mean, including prices, including tool life, we put in our software called Tool Reporter, and after that we are printing it, or we are converting to PDF and send to the company which needs this report, and we need this report also to show that sometimes price of tool is not that is the biggest value, but the biggest value is what it can do, how it can shorten the time of machining. Very interesting question. Why Vidya use diamond as a symbol? So some weeks ago we had a seminar about carbide production. So the first carbide in the world called Vidya in 1925, and Vidya, it's a combination of two words, via diamond. So German word, German language, which can be translated like diamond. So in 1925. The hardness of this tool material, the first carbide in the world, was much higher than hardness of high-speed steel, and also much better hardness than other materials, which were slightly hard but brittle, and so on and so on. So some compare it with diamond, and some started to use this material instead of diamond in earthworks, for example. So if you need more information about that, examples of calculations, maybe even this file, please contact us, or contact in the also give to you your information about you, or contact to your nearest video representative. So this is all questions I can see. If Isabel, you can see other questions, please.
No, Vladimir, I just wanted to reinforce what you said. If you would like the Excel file or any more information, please write us an email. I left my email in the chat, so then I will get back to you, or Vladimir, or as he said, our sales representatives.
Also, this file is not ideal because I didn't show to you how it can be calculated, the cost of tool, the tool which can be reground. So basically, there should be another numeric column added, how many regrindings can be used, and also some economics from regrinding, because regrinding is another machine tool. It also should be considered and so on. Or there should be fixed price for regrinding from the regrinding supplier and so on. So it's also possible to use that there. Why lubrication is not used? I don't know, but usually it's very small and it is more or less constant value. So basically, it will not save money. I mean, only if you deduct it in the one variant and use in another variant. But very often, lubrication is permanent or not used at all, or used for both variants. So from my side, that's all. Thank you very much, and see you on the next webinars. Isabel.
Thank you, and see you next time. Bye-bye.